Hello everyone. In this video, let's try and solve this problem. Determine the neutral axis, center of tension side, and center of compression side for the figure below. Assume tension is above neutral axis. So we have, this is the figure for the given problem, wherein it is a built-up section of a plate above the W1088 wide flange. Now to solve this problem, we need first the properties of the W10 by 88, which we can obtain from the Steel Manual PDF, which I provided for you in our module, where we will have, or where we can see that the BF of the W10 by 88 is 10.3, the D, or the depth of the wide flange, or the H, is 10.8 inches, the thickness of the flange is 0.99 inches, the thickness of the web is 0.605 inches, and the gross cross-sectional area, or the total cross-sectional area of the W10 by 88 is 26 inches squared. Okay. Now we need to determine the location of the neutral axis. Now in this layout, we already know that along the horizontal, it is at the center, the location of the neutral axis. So we already know that. What we do not know is the location of the neutral axis along the vertical. This one. Okay. That is what we need. Okay, now, to solve that, to solve the location of the neutral axis along the vertical, we can try and solve it by setting the bottom part of the wide flange as a reference x-axis. Okay? Wherein the distance between the x-axis and the neutral axis, this would now be the y along the, or the y and a. Okay? Now, to solve the y and a, the location of the neutral axis on the vertical, we can try and use the centroidal formula, wherein we would have the y and a, if you multiply it with the total area which is the area of the wide flange plus the area of the plate, is equal to the area of the wide flange times the y of the wide flange plus the area of the plate multiplied by the y of the plate. Okay. Now, of course, if this is for the D, or the depth of the flange, then the location of its center is D over 2. Okay. So we can have it in this part. Okay. D over 2. Now, while the location of the plate is over here, so this now becomes D plus half of the thickness of the plate, which is 1/4. So half of 1/4 is 1/8 inches. So that is D plus 1/8 inches. Okay. So we now have the y, we need to solve the y and a. We have the y of the flange, which is D over 2. The y of the plate is D plus half of 1/4, or 1/8. We now need the areas of the wide flange and the plate. We already have the area of the wide flange. The area of the plate is 12 inch times 1/4 inch. So we would get 12 times 1/4, that is 3 inches squared. So that the total area is 26 plus 3 is equal to 29 inch squared. So we have 29 inch squared. So solving it, we have y and a times 29 is equal to the area of the wide flange. This is 26 y of the wide flange, that is D over 2. Our D is 10.8, so 10.8 over 2. Okay, plus the area of the plate, which is 3, times the y of the plate, that is D is 10.8 plus 1/8. Okay, we only have one unknown, which is the y and a. So solving it, we have here cross multiplying 29, so this is 26 times 10.8 over 2 plus 3 times 10.8 plus 1/8. Okay, so you have it here. Yeah, 26 times 10.8 over 2 plus 3 times 10.8 plus 1/8 all over 29. So we transfer 29, cross multiply to the other side. So the y is 5.972. 5.972. This is inches. Okay, 5.972 inches. So we now have the first answer of our problem. Next, we now solve for the center of tension and the center of compression. Now, as stated, this would be the tension side, and this is the compression side. Okay, tension side is above the neutral axis, while the compression side is below. Okay, tension is above neutral axis. Okay. Now, to solve their corresponding tension and compression side, we need to cut our figure at the neutral axis and then solve individually. Let's start with solving the compression side. Now, let's cut at the neutral axis. So, cutting at the neutral axis and only using the bottom part. So, we get something like this one, where this is now B. Okay, now, what we need now is the centroid or the center of this area. To solve it, we can still apply this centroid formula. Now, if you notice for the shape of the wide flange for this one, it is going by the curve. So, we can try, and what we can do is, we can assume this to be perfect rectangles. Okay, wherein this will have now the thickness of the flange. Okay, of course, this is the thickness of the web. We can set our figure to be two rectangles, one horizontal and one vertical rectangle. Okay, now we need this dimension. Now, what is this? This one is actually the y and a. Okay, so if you notice over here, this is y and a just below the neutral axis. So this is y and a. Now, what is this dimension? So that is y and a minus tf. Since this is thickness of the flange, so y and a minus thickness of the flange. So we can have this will now have two areas. So let's have this as area 1 and area 2. The area 1 for this one is thickness of the web times y and a minus tf. The thickness of the web is 0.605 times the y and a is 5.972 minus the thickness of the flange. Thickness of the flange is 0.99. Okay, solving it, we'll have the area 1 0.605 times 5.972 minus 0.99. Here we have this one, 0.605 times 0.602. Okay, this is 3.01411. 3.01411 inches squared. For area 2, that is simply thickness of the flange times B. Okay, we have the thickness of the flange is 0.99 times the B or the BF, that is 10.3. So area 2 is 0.99 times 10.3, 10.197 inch squared. Okay. Applying the let's have our reference. Okay, x-axis over here. so that the location for the center of the compression area, the center of the compression area. So let's have this as YC. Okay, YC. So that YC times area total for the compression side only is equal to area 1 times Y1 plus area 2 times Y2. Okay. So YC times the area total is 3.01411 plus 10.197. We have 13.2111. 13.21111. A1 is 3.01411. Now what is Y1? Okay, we have the x-axis here. Y1, the center for the rectangle is over here. So this is, let's have it here. For the Y1. Y1 is actually TF plus half of YNA minus TF. So TF plus YNA TF half of this one. Okay. So TF plus the half of this side. So this is TF plus half. So this is YNA minus TF all over 2. Okay. So we have it here. TF plus YNA minus TF all over 2. Okay, this one. TF. So let's try to solve this to simplify. TF is equal to 0.99 plus YNA is 5.972, 5.972 minus TF 0.99 over 2. So this is, okay, 3.481. 3.481 inches. So Y1 is now 3.481. 481 inches. Now let's move to area 2. The area 2 is 10.197 times Y2. Y2 over here is simply the area or the center, which is TF over 2, the half of TF. Half of TF is 0.99 all over 2. So in this one, we only have one unknown. So we have the YC, or the center is, let's have it here, 13.21111. This is 3.01411 times 3.481 or 81 plus 10.197 times 0.99 all over 2. Okay, so this is 3.0114 times 3.481 times 3.481. Then we have 10 point plus 10.197, 10.17 times 0.9 over 2 all over 13.11. 13.1 cross multiply. So we have the center of the we have the center or the YC is 1.176. 1.176 inches. Okay, this is now the center of compression located from the bottom part or the reference y-axis. 1.176. Okay, that is the center of the compression side. Next, we need the center of the tension side. So center of the tension side, we draw the tension side, and still we will still assume that the wide flange is in perfect rectangular form. So this is the plate, the top one, This is the flange of the web, the W10 by 88, and this is the web of the W10 by 88. And this is the neutral axis. Okay. Now this time, let's have our reference x-axis on top. Okay. Of course, what we need is the assuming this is the YT, or the tensions, the center of the tension, area, where this will be the YT. Okay. And the question is, how much is this one? And that one is actually D plus the thickness of the plate minus Y and A. So this is D plus thickness of the plate 1/4 minus Y and A. So this is now D plus 1/4 minus Y and A. Okay. We have the D is 10.8. 10.8 minus 1/4 minus 5.972. 972, that is the Y location of the neutral axis. So 10.8 minus 1/4, plus 1/4 plus thickness of the plate minus the Y. So this is 5.078. 5.078 inches. Okay. Just checking, if we add the D and the thickness of the plate, it should be equal to the YNA plus this value. So basically, this is the YNA, and this top side is this one's top side. So let's check. D is 10.8 plus 1/4. The answer is 11.05. Now if we add 5.972, which is the YNA 972, plus this one, plus 5.078, this should be okay, the same, no? 11.05. It's just the same, 11.05. So we now have the total length for this one. Now this is the thickness for this one. This is the plate. This is 1/4. This is also the thickness of the flange, or the TF, thickness of the web. Okay. So this part here, this should be the 5.078 minus TF and minus 1/4. So 5.078 minus 1/4 minus TF is 0.99. I believe 0.99 is TF. Okay. TF is 0.99. So I repeat, the total height of the tension side is 5.078. You subtract 1/4 and TF, you will obtain this side. So that is 5.078 minus 1/4 minus TF, or minus 0.99. We'll get 3.838. This is 3.838. To solve for the Y tension, let's now try and solve first the areas. You have one. Now let's name this area 3, area 4, and area 5, since we already used area 1 and area 2 in the compression side. So area 3 is 1/4 times this is 12 inches. Okay, so 1/4 times 12 inches, this is 3 inch squared. Okay, from this one, 12 times 1/4, 3. Next, area 4. Area 4 is this one. That is, its width is B. Okay, so this should be B. The B is 10.3. Okay, 10.3. So 10.3 times thickness of the flange, or 0.99, area 4 should be 10.3 times 0.99. Okay, so we have 10.197. 10.197 inch squared. Finally, area 5. Area 5 is this one, 3.838 times the thickness of the web. So 3.838 times the thickness of the web is 0.605. Okay? 0.605. So you have 3.838 times 0.605, 2.322. 322 inch squared. Okay, and then we have the total areas for this one. For the 345, the total area for 345 is 3 plus 10.197 plus 2.322, 15.519 inch squared. Okay, so applying the centroid formula, you now have the y of the tension times the total area, 15.519, is equal to area 3, this is 3 inches, times the center of area 3 with respect to our x-axis above, that is simply half of 1/4. Because it will be here, this is 1/4, so half of it is 1/8. So 1/4 all over 2. Okay. Plus, next, area 4. Area 4 is 10.197. Then the location of area 4. Location of area 4 is over here, so that is 1/4 plus half of TF. So this is 1/4 plus half of TF. I believe TF is 0.99. TF is 0.99. So 0.99 over 2. Plus area 5, that is 2.322. Okay, area 5, center of area 5 is somewhere over here. Okay, so that is 1/4 plus TF plus half of 3.8, because it will be located half over here. So this TF, I mean 1/4 plus TF plus half of this one. So this is 1/4 plus TF is 0.99 plus half of 3.838. Okay, so this should be our equation. We only have one unknown, so YT. So this is 3 times 1/4. This is actually 1/2 of 1/4 is 1/8 plus 10.197 times this 10 times 1/4 plus 0.99 over 2. Then we have plus 2.322 times 1/4 plus 0.99 plus 3.838 all over 2. Okay, so 15.519. Okay, so a recap, this is 3 times 1/4 over 2. So you have 3 times 1/4 over 2, that is 1/8. The next we have 10.197 times 1/4 plus 0.9 over 2. So we have 10.197 times 1/4 plus 0.99 all over 2. Next, we have 2.322 times 1/4 plus 0.99 plus 3.838 over 2. And then, quantity all over 15.519. That is this one. We cross multiply. So the answer is 0.986. 0.986 This is inches. Now, what does this mean? We now have approximation for our figure here. It is here. Okay. So, the center of the tension side is over here. This is the y, or the center. The tension side is 0.986 inches, while the center of the compression side, this is also equal to 1.176 inches. Okay, now what we are really this is important to determine the center of the tension side and center of compression side to solve this one, LA, because that is what we need in our solution for the analysis of built up sections. How do we solve LA? Well, we need the total length, no? This is D, which is equal to 10.8 inches, and this is 1/4. So 1/4 plus 10.8 subtracted by these two values, so this should be 10.8 plus 1/4 minus 0.986 minus 1.176. So LA should be 10.8 plus 1/4 minus 0.986 minus 1.176. So we now have 8.888 inches. Okay, but know that the question of the problem is simply the center of the tension side, center of the compression side, and the location of the neutral axis. Okay, I just shown LA here because this is the one that we actually need for the analysis of built-up section, which can be obtained by determining first the center of the tension side and the center of the compression side. Okay.